All right, good morning, IB Math. Welcome back. We're going to continue with our Descriptive Statistics, Part 3 here. And what I'd like to do now is I want to take a closer look at some histograms, some other types of histograms, and talk about the characteristics of a histogram. When you're looking at one or looking at a frequency table, what can you tell? What are you looking at? What information is being presented? How do we analyze it? What is the meaning of the data? So the best way to do this is obviously to look at a bunch of histograms and just talk about them. But before we do that, let's establish some words and some vocabulary that we're going to use. So we're going to look at the distribution of the data. Distribution. What do you think of when you think of the word distribution? How are we going to use the distribution here? So we're going to look at some of the key features. How is the data arranged? And there really are four key features that we need to look at when need to think about when we're looking at a histogram. Four of them. First, we want to look at the center. Now, the center is where we would use our measures of central tendency. This is where we would look at things like the mean, the median, the mode, and the mid-range. And all of these tell us about how tightly the data is grouped around the center, the measures of central tendency. And from a histogram, we can actually calculate and look at these things and get an idea of what they're going to be. The second thing, when looking at a histogram, we want to look at is the spread. If the center is looking at all the stuff that's happening in here, the spread is looking at all the stuff that's happening all around it. And of course, we know the three measurements here would be the range, which would include things like the maximum and the minimum. And then we're talking about the interquartiles, the different quartiles and the interquartile range, and of course standard deviation. I know we haven't talked about standard deviation very much yet, have we? It's a whole big calculation. There's a whole big to-do here. And we'll look at this, we'll do one by hand, but then most of the time after that we'll do it all on the calculator, and we'll talk about, well, what does this mean? What is this telling us? There's a lot of information about standard deviation coming up a little bit later. What else can we tell by looking at a distribution of the data? What else can we tell by looking at a histogram? The next thing we want to look at is something called outliers. Outliers are pieces of data that are way out from everybody else. For example, remember when we did siblings? If we were talking about siblings and it seemed that everybody had 0, 1, 2, or 3, if there was one person that said they had 7 siblings, this person's way outside of our data set. That would be an outlier. There is actually a whole way of calculating what an outlier would be. An outlier is defined as a data item. An outlier is a data item which is more than (1.5) times the interquartile range. 1.5 times the interquartile range, above or below. So whatever the interquartile range is, multiply that by 1.5, and if the data piece is more or less than that away, then that would definitely be an outlier. The other thing we want to look at is just taking a look at the basic shape of the thing. And when we look at the shape, a couple of things we want to think about when we look at the shape is, and you're looking at just the overall shape, is it unimodal? Is there just seem to be one class that's definitely bigger than all the other ones? Or is it bimodal? Is there two, like a camel with 2 humps? Is there 2 or not? I mean, it could be multimodal, which really isn't a thing. When we talk about modes, there's either going to be one mode or 2 modes or no modes. And what about its stretching? Is it symmetric? Or is it skewed? Is all the data gathered at one side and all at the other side, just like our number of siblings data set? Is it symmetric? Is it a nice even curve? It kind of reflects over the middle. These are all things we need to think about. So let's take a moment and look at some graphs. And I apologize, they're not very big, but they're in our textbook. I want to take a look at some graphs here. And I want to just look at and talk about the graphs and their characteristics. So in the first graph, unimodal. Because as I look at it, there's clearly one mode. I also notice that this one is fairly symmetric. It almost gives me a nice bell curve. It's not skewed one way or the other. But this would be a unimodal. Clearly there's one class that's bigger than the other. This one looks more bimodal. I've got a grouping here that's frequently occurring and a grouping here. And this is clearly not nice and symmetric, something that's going on here. Now this data set here, they're calling it multimodal. Really there is no such thing. It's just, this I would actually say has no mode at all. I've got a lot here, a lot here, a lot there. I've got a little bell here, a bell here, and a bell here. It's not symmetric. It's just, there's no really one class that occurs statistically more than any others. There's really no mode in here. And then this one, notice how all the data is already pushed all the way over here. This is skewed. All the data is skewed to one side or the other. When we're describing these, we want to use words like if it's wider or narrower or very varied or not very varied at all. And looking at this data, we can also make estimates about the mean, the median, the mode, the range, the mid-range. If you can't calculate it directly, we can make estimates based on our different frequency tables. All right, so let's actually do that now. So now I'm going to look at another example, and we're going to talk about it. This is in our textbook as well. And again, I apologize, it's not that big. Here it is. This is example 5 on page 325. So just take a look at this data table here. I wish I could make it a lot bigger. If I was in class, I'd sketch it on the board. If you've got your textbook, you can open it up to page 325 and take a look at it. So this data, this is from a frequency table. This histogram is from a frequency table that shows the length in centimeters of 51 different fish. 51, they were very specific with this number. You know that's going to be important in a moment. 51 fish that were caught in the river Avon. So this is the length in centimeters of the fish. And as I take a look at this. So what can we tell from this data? So if I take a look at the general shape of this data, is it skewed? Is it symmetric? What's going on here? It seems kind of symmetric. Not really. This kind of throws out of it. What about mode? This definitely seems unimodal. It definitely has a modal class. All right, so what information can I tell? Can I find the median fish, the middle class fish? Well, it has nothing to do with the biggest, these biggest ones here. It has to do with 51 fish. So I would need to count in to the 26th data point. So I would count into my 26th data point, which actually would be in this data set here between 60 and 70. So the modal fish would be in, the median fish would be here in the modal amount of fish too. Clearly that's the modal class. Most fish were between 60 and 70 centimeters. What about the range? Can I tell anything about the range of fish? Well, it looks like the smallest fish was around 20 centimeters. The biggest fish was around 120 centimeters. So the range would be 120 minus 20 would be 100 centimeters. There was a range of about 100 centimeters in the fish, between 20 and 120. Just looking at the distribution, what can I tell things about the center and the spread and the outliers and the shape, the things we just talked about? The center is going to fall right here in the middle between 60 and 70. The mode, the median, the center is all going to be right about here, I would think. The spread varies from 20 centimeters to 120 centimeters. What about outliers? Are there any outliers? No. I would need to know the interquartile range, but even if I didn't know that, if I had a fish over here, some monster fish that was 180 centimeters, that was way over here somewhere, clearly that would be an outlier. The outliers definitely affect our data, affect some of the measurements of the data much more than others. And what about the general shape? I keep saying that this is the modal class. Clearly that's a mode, but I've got another one here. Maybe the data here might be a little bit more bimodal, because I definitely got a large grouping here and then a large grouping here. Most of the fish are between 60 and 70 or 90 and 100. So if I say between 60 and 70 or 90 and 100, that would seem to insinuate that there are two modes. This is a bimodal data set. So as we're looking at histograms, if I had the frequency table, I think I could be a lot more accurate in doing some of these calculations. But just looking at the different class widths, looking at the general shape, looking at the spread, the center, saying if there's any outliers, what's the middle class, what's the range, all these different things tell me a lot of information just from looking at the frequency table, or just by looking at the histogram from the frequency table. All right, so I think we're ready now at this point to go on and do the next homework assignment. There's another example where you can see all the data from this in the textbook if you want to take a closer look on page 329. But I think at this point we're ready for the exercise. Although from the exercises we're going to do 5D, but problem number 2, since I'm not there, we're not going to do problem number 2. Problem number 2, I was going to do it in class. We were going around and ask everybody on what day of the week were they born. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. And then we were going to create a histogram and a bar chart. It was going to be an example that I did in class. So you don't have to do number 2, but go ahead and do the rest of 5D. Good luck, and I will talk to you for the last part of this lesson coming up here in a minute.